Well, thank you very much, Martin and Sydney, for inviting us last week. We're happy to be here. So my name is Venkatesh, as Sydney introduced me, and I'm with the Irish Centre for High-End Computing. Just by show of hands, how many of us are already familiar with what we do? That's good. So I have something to deliver for the rest of you and maybe update you with the more recent activities that we are doing. So the role of ICHEC, just from a very high level perspective, by state mandate, we are the National Supercomputing Centre in Ireland. And we are funded by a couple of the government departments. We have two offices, one based in Dublin and one based in Galway. And we have our data center in Waterford. So, and our main purpose from the point of view of the National Supercomputing Centre is to deliver the national HPC service to academia and researchers within Ireland, and also support the enterprise community in leveraging HPC for their solutions. And so through that, we also engage with the public and private sector agencies and bodies within Ireland, and that's through a range of engagements. We do state co-funded engagement, we do commercial services, and we also engage through public competitive funding model as well. In the broader sense, with the recent developments of the Euro HPC JU, we are the designated national the competence center for Ireland, and what that means is we again deliver the same mandate, but also in the context of the Euro HPC, and our primary focus in that context is to deliver performance engineering and energy efficient HPC application development for academia as well as enterprise organizations. So that's our primary focus. And also a part of the competence center will be the enterprise accelerator program, where we have a triangular model where we engage with technology makers and technology takers and act as the intermedium, where we deliver the expertise in working on the different HPC platforms to the SME and enterprise organizations. And we also engage with BSc recently. We have worked with them in the past, but more on a more formal scale now, where we are a part of the consortium for the pre-Exascale system that's going to be put in place at BSc, and we'll be working on delivering the HPC service through that platform. Just a very high-level view of the range of domain experience and expertise that we have at ICHEC. Naturally, we work on HPC, but on quite the spectrum, which is at scale towards Exascale, but also on power-budgeted edge computing platforms. So we address energy efficiency at scale and on specific devices, and naturally performance engineering on heterogeneous computing platforms. We've been doing that for a while now. And of late, this is not riding the wave, but in quantum computing, we see the opportunity to explore the programmability of the systems that are being put out there or being designed at the moment. So it's just about an exercise to identify what the programmability challenges for these systems are in terms of mapping algorithms and even identifying applications that are suitable for these kind of platforms. So it's more of a POC and exploratory scale, and coming up with industrial use case POCs with, again, the technology makers and the takers in the picture. In terms of AI, we are pretty much focused on data science, machine learning, that includes deep learning as well. And again, addressing efficient training of the deep learning models on HPC systems, and also on developing more efficient models for deployment in edge use cases. So I'll go into one interesting edge use case for deep learning inference. We also are recently looking into federated training in the context of deep learning models by leveraging blockchain as a platform for data storage for specific use cases. So that's again steered by, probably I don't have a slide on that, so maybe I'll just say one more word. So recently there are different applications that ESA sees in using blockchain as a medium to host the Earth observation data sets across distributed sites, and deploying distributed training on blocks of these chains. The idea there is when commercial entities want to leverage the Earth observation data sets, they might not want to expose their data sets and their models. So this allows a more secure distributed training, so to say, and secure training of their deep learning models. And finally, we also work, we have a long-running and strong activity in environmental sciences, which spreads across climate and weather modeling and forecasting, geophysics data sets, primarily focused on seismic data sets at the moment. We also work with Earth observation data sets, primarily from the Copernicus program, and also recently in the hosting and management of health data sets within the Irish context. We also are leading into filling the gap in terms of the dataset availability for Earth observations, because depending on the coverage and granularity, you might find gaps both temporally and spatially in Earth observation datasets. So augmenting them with UAV-based datasets and bringing them closer to filling the gaps with ground sensor datasets. So integrating the different datasets at different resolutions, and that's one of the things that we're doing. And naturally, we don't keep all of this to ourselves. We actively engage in training and dissemination of both the domain and technical knowledge that we have with the academic and enterprise communities. Just a brief word, so just to highlight different aspects of what I mentioned in the previous slide through some of the works that we're doing. First up, with respect to the move towards exascale computing, our engagement has been primarily through the Horizon 2020 framework. One of the projects, ESCAPE, it was briefly mentioned yesterday as well. We were a member of the consortium there. And primarily, just to summarize again, our work was primarily on working with the algorithms in the building blocks of climate and numerical weather prediction models. And these were termed as dwarves in the context of this project. And the objective was to optimize the algorithms of these dwarves themselves and then implement them for specific compute architectures, primarily focused around x86 and GPU. The second aspect of our exascale experience in terms of energy efficiency was the REDX project, which takes the view that a long-running application, which is primarily a loop-based iteration, so to say, it might be a time loop or a simulation loop, would express behavior which has dynamic resource requirements in the context of the type of the computation or data communication that's happening. So the objective of the REDX project was to model the dynamic behavior of an application over time and use that information to decide on tuning actions across different parameters in the entire HPC stack, starting from the hardware, system software to the application libraries. So the objective there was to be able to model an application during its runtime and then make tuning decisions. The results were promising. we used a bunch of benchmarking, standard HPC benchmarking suites and production applications from different consortium members that are available. Ballpark 15 to 20% of saving was possible with respect to energy consumption, but then the primary challenges that came out of this was the instrumentation and profiling of the application in an efficient manner to be able to do the modeling. So that's still kind of an open question, both from a compiler, if automated compiler instrumentation or manual instrumentation, both have their pros and cons, but primarily enabling or preparing the application for this kind of efficient telemetry information gathering is the key challenge there. And once that's doable, then modeling and getting some energy savings out of the tuning, that seems pretty doable. So delving a bit more into the environmental sciences activity, as I mentioned, we address primarily the HPC and HPDA aspects of weather and climate forecasting in the context of Earth modeling systems. For example, our Earth observation activity primarily revolves around the Copernicus program in terms of leveraging the EO data sets since they're openly available. Two primary things that we do is that we prepare the EO data sets for ready use by the academic and enterprise community, and that involves, if you're aware of EO data sets, then there are different levels of readiness at which you can get them. L1 is directly what you get from the satellites, L2 is pre-processed, and L3 is problem specific or application specific. And so there needs to be a certain pipeline and the workflow to use a set of GIS tools to clean these data sets and prepare them for commercial and research exploitation. So we do a lot of that as well. And we develop tools to semi-automate this to as much an extent as possible on HPC platforms. The second thing is, of late, ESA has been working with us in developing a tool chain and a platform to prepare AI-ready Earth observation datasets, because preparing datasets is a challenge as it is, but then Earth observation datasets need a lot of domain expertise to be able to prepare them. So you might have to overlay images, so to say. If you are dealing with images, then you might have images from different satellites, different sensors, and then you might, and depending on the region, you might have to do georeferencing with GIS-specific tools. So there is a lot of domain expertise and domain tools in preparing EO data sets. So we are working on a platform, again, with ESA to enable AI-ready dataset preparation, AI-ready EO dataset preparation there. And then with SkyTech, which is again an enterprise, an SME in Ireland, we have deployed EVDC, which is basically a platform that allows both aggregating, which is archiving, and enhancing the datasets, and also it's a platform that ESA uses to evaluate the availability and quality of all of the Earth observation datasets that are made available. Going a step further, what we have done is just focusing in the context of Ireland and Northern Atlantic region. We have the Copernicus data available through the ESA portal, but then there are challenges, meaning they are L1 data, and then the number of parallel streaming downloads that you can get from them for academic or commercial use, they are free, but it's very limited. So what we have done is, for the context of Ireland and Northern Atlantic, we have prepared a platform called SPÉir, Satellite Platform for Ireland. And what this platform does is it hosts the Sentinel-1, 2, 3, 5P data, which are the satellites that are available right now, but it will be going beyond those as well as the other satellites that are launched. These data sets are cleaned and their L2 versions are prepared and hosted in the platform that's made freely available for academics, researchers, and commercial users. It's open not just for Ireland, but for the rest of the world as well. And on top of them, we offer containerized HPC and AI toolkits and solutions as well, and we support development of applications on them. So recently we held a hackathon where companies and students were basically leveraging this platform, and it was quite well received. One other thing is the data sets that we aggregate, they aggregate pretty quickly. So we expect to reach multiple tens of petabytes within the next 3 to 5 years, which is again a challenge in terms of putting the infrastructure in place and growing. And in terms of climate research, our researchers engage again in simulating the global climate change scenario with the EC models, and these data sets have fed into some of the climate reports. These are growing extraordinarily, but what we also do is we downscale these data sets for use within the Irish context with higher resolution, up to around marginally less than 4 kilometer resolution for projections. And where that feeds into is state agencies and departments use these projections and data sets again to feed into their regulations and policies. The Environmental Projection Agency is one that we closely work with to generate these reports, and that feeds into their pipeline. And again, we simulate the climate over Ireland in a much higher spatial resolution of around 1.5 kilometers. Again, this has implications through, again, agencies in the agriculture, socioeconomic, public health sectors, and so on. And recently, HPC and more edge AI is coming up in this horizon of ESA as well. Already an Italian satellite called TIVAC is up. I think it was launched in June this year, if I'm not wrong, and it has on board the Intel Movidius Myriad 2 processor. And the objective there is to do onboard image analysis in a pre-processing level. And if you look up FESAT 1 and 2, FESAT 1 is due for next year, 2020, and following that FESAT 2. So all of these satellites are taking on board edge computing platforms for particularly focused on inference, deep learning inference. And we are working with ESA and an SME again called Ubotica to use the Italian SAT and develop a platform that allows pre-processing of Earth observation images on these platforms, but also update the models in orbit. Because the key is once the models are deployed, and if you observe new scenarios through your data sets, then you might want to update the models. So there needs to be a workflow and optimization mechanisms to upload weights, so to say, to update the models in orbit. And with the uplink speed being in kilobits per second, a few orders of kilobits per second, that's quite a challenge because our models can easily reach gigabytes. But if you want to make any reasonable updates of the models, you need to prune them and condense them for this specific use case. So the objective there, again, a bunch of arrows, but the objective is the onboard inference will result in high-level meta information being passed down in the downlink rather than all of the images which are streamed currently, but also selectively downlink images that are relevant. And that goes to the data center, which will be analyzed to update the models, which will be again then uplinked to update the model. This also feeds into efficient energy utilization on board, a tighter reaction to critical events that may be observed on ground. One of the use cases that is critical in the context of ESA and even national security is wildfires within Ireland. So we are going to develop a couple of use cases on top of this platform to demonstrate the relevance of this. So that's due to start October. It was due to start in June, but red tape, it's due to start in October. And potentially, this platform will support all of the satellites that will have inference engines on board and allow for different HPC infrastructures that ESA is developing in the context of Earth observation data processing in the back end. So going forward from environmental science and Earth observation, we also work with the public sector particularly for the health data analysis. So this is an example of a project that is funded by the Health Research Board that looks into all of this. And the project revolves around putting in place a platform called DASSL. And the purpose of this platform is to demonstrate to the health sector how different data sets from the institutes engaged in the health community in Ireland can pool off all of the data in a central location, do linked analysis, and this will be demonstrated by 3 specific use cases. I wouldn't go into the specific use cases. For example, one deals with how drug or alcohol level has an influence on people diagnosed with epilepsy. So there are similarly 3 different use cases, but the objective is to work with data from different organizations in the health sector and how to do linked analysis and then address naturally the policy and ethics regulations that should be implemented on such a platform. So it's just not HPC, but also the ability to study how policies and ethics and data protection guidelines can be implemented within the context. Again, this is just another example of our engagement with the public sector, the Central Statistics Office in Ireland. We worked with them to put together a sandbox, from data from different sectors, say health, transport, infrastructure, economic satisfaction, and so on. So different data sets gathered by the Central Statistics Office, put together in a single sandbox for cross-sectoral linked data analysis. And this has been open for a long time, more than 25 organizations, including the EOCD and Eurostat, have been using this for their studies. As we say, Ireland is small enough for a trial, but large enough to prove. So that's kind of the motive behind putting these kind of sandboxes and test cases in place. And we also use this platform again to upskill and train the public sector organizations in terms of HPDA and HPC on this platform, on this sandbox. On the geophysics side, I'm not sure if you're aware of the challenges in dealing with in seismic data formats. So primarily SegY and size are some of the most commonly used data formats, and they are non-contiguous. So a single large blob would never sit continuously in memory. So you'd have a header followed by blocks, and each block is a trace and data. And these blocks won't sit next to each other either. So doing I/O with them, let alone HPC, is a nightmare. And all of the oil and gas codes are using this data set, using this data format. So parallel I/O is the first thing that we needed to deal with before even thinking about porting or implementing parallelized full wave inversion or real-time migration codes on top of them. And this project, ExasCale, primarily focuses on developing workflow and parallel I/O libraries for oil and gas applications for the commercial partner Tullow, and using the DDN platform. So what we do is we develop a parallel I/O library which kind of works at the application domain level and automatically parallelizes using MPI. And the basic workflow in oil and gas would span sorting, filtering, and doing transforms, and so on. So it's pretty straightforward to implement the workflow and do automatic parallelization, but the challenge is then to take advantage of the burst buffer technology, say the IME from DDN, and updating all of this libraries to take advantage of RDMA. Another thing, and we are also looking into NVMe, where we can pre-process some of the data and store it in NVMe if the computations are going to operate on them for quite a long time. And going ahead, with Lustre being acquired by DDN, what is also of key interest to them is also looking on how to more tightly integrate the tape storage with Lustre, primarily in the context of Amazon S3, starting as a starting point. So we are looking into developing customized file system drivers to enable optimized transfer of data from traditional tape storage, which is usually found in oil and gas industry, onto Lustre, and hence taking better advantage of the cloud platforms. Again, this is a slide with too many things. What I will highlight here is just the spectrum of the use cases that we deal with in terms of engaging with commercial partners. So you might see Brown Bag, which is an SME that automatically generates subtitles for films. So again, we used NLP to take the audio data sets and generate text for different languages. For example, maybe I'll highlight one interesting use case here, which is the one with ULG. So here the objective was ULG, United Language Group, are in the business of translating documents. And the documents may be from multiple domains and from multiple languages. So you might have health documents to translate, financial legal documents to translate, so different context of the language in terms of the semantics as well as the literal language, so to say. And their challenge is they want to leverage the cloud platform to do all of this, to provide this as a service to their customer. And depending on the linguistic structure of the languages and depending on the domains, the models may have to be retrained, so there's a training aspect involved as well, but also there's a cost for the inference. And that will change depending on which pair of documents you're going to work with, your source and destination. And they wanted to deliver a model to the customer. ULG wanted to deliver a model to the customer where they say, if you use these many resources on this per package that we offer, then you'll get the translation within 2 hours, or you may get it within 2 days. And that flexibility in providing a cost model to the customer needed under the hood is evaluations of how do I scale if I do distributed training, and if I do a single GPU training and inference, then how many models can I fit, how long will it take? So it involved evaluating using the OpenNNT framework for their use case, but then again evaluating it on a single GPU environment, on distributed GPU environment, multiple models on a single GPU, multiple models on distributed GPU, and so on. So we had to go beyond evaluating the performance, but also work with ULG in defining the cost model in addressing this specific use case. And more recently into quantum computing. So since Q2 2018, we started looking into, is quantum computing viable? And if it is, I mean, the jury is still out. We'll not know for the next 5 to 10 years at least. But with the NISQ platforms and the simulators that can be deployed on HPC systems becoming available, we saw it worth to investigate what is the programming paradigm going to look like for quantum computers, at least the gate-based ones. And if we understand the paradigm, what are the challenges in mapping the algorithms that are suitable for quantum advantage onto these platforms. So again, just like we address any other HPC platform, we are working on identifying potential use cases that benefit from the quantum computing paradigm and developing proof of concepts with technology takers for these platforms. So just a quick highlight, we are working with Intel on developing a quantum natural language processing solution. With Accenture on the Rigetti and Google platform, we are going to work on analyzing molecular chemical reduction of a class of environmental pollutants called PFAS. So again, it's of much interest to the state of Michigan, and also fortunately within Ireland, we don't have a high concentration of PFAS. And going beyond, we are also kicking off work in leveraging algorithms that can help with asset management, portfolio analysis for the fintech industry, and also optimization problem is something that the quantum computing platform can can benefit. So aerospace engineering design, so particularly designing and engineering the components in aerospace engines is an optimization problem. So that neatly fits in here as well. And all of these are practical works that are ongoing or are going to start soon. And in training and education, this is broadly AI, but again, I'll take that with a pinch of salt, which is again focused on data science and analytics at scale, and also deep learning and machine learning. We have different ways of delivering these trainings in this context, which is we do a quick CXO engagement to brainstorm the relevance of whether a particular organization or entity can benefit from machine learning, and then we have an intensive onboarding where we deliver over a period of 2 weeks hands-on training, and then we have one-to-one engagement, and we also offer, along with University Limerick, the National Masters in AI, which is primarily industry-driven. So all of the participants are full-time employees which take part in the course. So it's in the second year now, and we've been seeing 100+ participants every year now. And that's being replicated across multiple universities. And again, we offer training on our quantum programming experience to the wider audience, academia and industry, and naturally we deliver HPC related training to the rest of the community as well. And our enterprise partners span both, as I mentioned, technology takers and makers, public sector, transport, CSO, the city council, EPA, so on the environmental sciences side of things. Cross-sectoral data analysis is something that we are getting on board, because the impact of transport on health data, impact of climate on health, that's something that's proving to be very crucial, both in the context of public sector and in the context of dictating policies. In academia, again, through the National Service, we work with a wide range of universities, all of them, but also in a wide spectrum of application domains. And we engage with the Irish state. Fortunately, being directly funded by the department allows us to drive home the importance of putting infrastructure and expertise in place for doing meaningful HPC and AI, because that's probably not straightforward in all cases. So having to complement commercial cloud services with HPC, that's the key discussion that we are having at the moment. But we do engage with many of the relevant agencies and departments within Ireland. And beyond Ireland, we actually work through the PRACE network, EuroHPC, and if you're aware of CLAIR, which is a confederation of AI researchers and experts, ETP for HPC, and we work with ESA as well. Thank you.